So I hope you found page 140. It got sort of cut off in the last video. And if, when you did those two, the answers were what is here, you didn't have to include the i's. They just wanted to know how many possible positive and negative roots. I included it because I just have to do that to myself. If you got those and you have no questions, then please proceed to the next part in the Nearpod. If you do have questions, then please stay around and we'll work it out. Alrighty, so where did these answers come from? Well, if there are no common factors to pull off, and the polynomial is in descending power, we can get the number of positive roots by just counting the number of sign changes. And this is supposed to be 4x to the 5th here. So it was positive to start, still positive, and then it changed from a positive to a negative, and then that negative changed back to a positive, so we have two changes. That's going to tell us there should be two possible positive roots. But because there may be imaginary roots lurking out there that we don't know about, we also have to consider that there are 0 positive real roots, just in case there's a pair of imaginaries out there somewhere. Now, to get the number of negative roots, we take the same function but put in a negative x. The 5th power in a negative number is negative, so this whole term is going to become negative 4x to the 5th. Put a negative x in and cube it, that's a negative, multiplied by a positive 2, so this is going to become a negative 2x cubed. Put a negative x in here, multiplied by a negative 5, that's going to make this a positive 5x with a plus 2. And then we'll count the number of changes on the negative value for the polynomial. So there's no change, negative stays negative, but here the negative becomes a positive. And then it stays a positive. So there's only one change. Therefore, there will be one negative root. Whether there are 2 positive roots or 0 positive roots, we are guaranteed one negative root. And that was all that the textbook asked for. Because this is degree 5, I've just been trained to go ahead and figure out how many imaginary roots there would be. We'd already accounted for 3 here. And that would mean there's going to have to be 2 imaginary roots. This is not right. This has no positive roots, just one negative root is all we know about, one real negative root, and that would mean we'd need 4 imaginary numbers. I have to fix this, sorry. And then we're on to the next problem. It's got 3 terms, descending powers, no factor. We are just going to count the sign changes. Goes from negative to positive, and then from positive back to negative. That indicates there are 2 positive roots, or there could be 0 positive roots if we step down by 2's. To find how many negative roots, we're going to put a negative x in the equation. Square a negative number becomes positive, but it's still being multiplied by negative 5, so that will stay as it is. Cube a negative number, it becomes negative, multiplied by negative 2, we're going to have negative 2x cubed minus 6. And now we count the changes, except that there are no changes. Starts a negative, stays a negative, remains a negative. So there are no negative roots in this problem. Don't go trying to find them, there aren't any. And because it was degree 4, if we had 2 positive roots and no negative roots, somehow there's got to be 2 imaginary roots out there. And if we had no real roots at all, there would have to be 4 imaginary roots. So the rule of signs will allow us, like in this case, don't look for any negative roots. In this case, there's only 1 negative root possible. If you get 1 negative root, don't mess with any more negative possibilities. So we're going to try some practice problems that take it all the way through, not just finding out how many roots there are.